Hey guys, today we're going to do 1.2. It looks like we're doing graphs of functions. So first we're going to start off with kind of a modeling and real life situation. So it is important to keep in mind that at any time mathematics is used to approximate reality. There are always limitations to the model. It is important to keep in mind what the independent and dependent variable will be. So remember, independent is the x value, dependent is the y value. It is important also, probably that word's supposed to be also. It is also important to think about the applied domain as opposed to explicit domain. So explicit meaning that if we were just looking at the equation, it would go off in both directions, usually. But if we're talking about an applied domain, so think about time. If we graphed anything over time, would we use negative numbers for time? No, we can't go -2 seconds. So we have a certain domain from 0 to whichever time we elapse. You also wouldn't go to infinity. You'd probably stop at a decent, convenient time. So keep that in mind. So let's look over example 1 here. The height h in feet of a model rocket above the ground t seconds after liftoff is given by. So height. The height is, and we follow this equation if the time is between 0 and 20 seconds. The height is 0 if we're greater than 20 seconds. Okay, so as you can see, we're hitting the ground at 20 seconds. Find and interpret h of 10 and h of 60. So first of all, when you look at h of 10, you got to figure out which equation we are solving for. So as you can see, 10 is between 0 and 20. So we are going to use this first equation right here. So 10 is our second. So we get -5 times 10 squared plus 100 times 10. Okay, so when we actually evaluate that out, we get 500. Now it says interpret. We just found it. Interpret means writing a sentence beyond that, what this number is. So we can say at 10 seconds, the rocket is 500, and we're in feet, above the ground. Okay, so h of 60. So if I find, and I'm going to put it over here so we can have some room, h of 60. Well, 60 is greater than 20. So automatically the height is 0. Okay, so we can say after 60 seconds, the rocket is, you can say 0 feet, you can say is on the ground. But anytime you see the word interpret, you're actually putting it in a sentence according to the situation, okay? Now, this one for B. Solve h of t equals to 375. So first of all, if it's a value 375, we automatically know we're not using 0 here. We're using this top equation. So -5t squared plus 100t equals 375. Now, where do we go from here? If you remember correctly, the best way to do this is to move everything to the left side. So we get negative 5t squared plus 100t minus 375 equals 0. The other thing we have to keep in mind, guys, is you are not using a graphing calculator. You're using your basic calculator. So the more you simplify it, the easier it will be to do. So as you can see here, there is a negative 5 in all of these. So I'm going to take out a negative 5, and I get t squared minus 20t plus 75. Now we have to think about factoring. What two numbers would multiply to give you 75, but add to give you negative 20? Well, that is going to be at negative 15 and negative 5. So we get negative 5 times t minus 5 times t minus 15. Of course, guys, I've been factoring for quite a while, so I can do that in my head easily. If you need more help factoring, make sure you call me over for some help when we work in class, just to practice that out, because there's no graphing calculator. All right, so that negative 5 does nothing, but we're asking what makes it 0. So what t there makes it 0? T equals 5. And t equals, in this case, 15. So it says interpret, so we have to write down at 5 seconds and 15 seconds, the height of the rocket will be 375 feet above the ground. Okay, there you go. Perfect. All right. So what we did here is this is pointing out that this situation is a piecewise function because we have one function, but it's broken up into parts. The first part is between 0 and 20, and the second part is after 20. Okay. All right, so now we have some pictures and some graphs of parent functions. Remember that parent functions are where we start, okay? Or in this case, this is the constant. This is just showing a graph of a constant. A constant is going to be your horizontal line, okay? It's not vertical because this is f of x, and vertical is not a function, right? Because we have crossing at 2 points. So this is your example of your constant. Then we have our basic parent function for the linear, which is f of x equals x. So we have some big things here. We have absolute value. This is the parent function. This is where it would start. Okay. We have quadratic, which is x squared. We have a cubic, x cubed. We have a reciprocal, which is 1 over x. So there's an asymptote, right, at the y-axis. We have a reciprocal squared function, so it's 1 over x squared. Again, we have an asymptote at 0 because we can't have 0 under the denominator. We have the square root function, so like kind of that rainbow, right? And the negatives aren't there because we cannot take a square root of a negative number. Remember, even roots, we can't do negatives. Cube root right there is kind of our square root and kind of, what do you call it? Rotated around almost, right? So, but under a cube root, we can have negatives, so it works out, Okay, and as you can see, and I'm going to put them back to back, a cube root and a cubic kind of are just twisted and flipped around, right? They're kind of the same there. All right, so let's go into what they're saying here with the graph. In finding the x-intercepts of a function, we note that the x-coordinates are found by solving f of x equals 0. For this reason, they are called zeros. So lots of times they can be called x-intercepts, solutions, or zeros. Lots of time, most of the time you're going to get zeros. Zeros is when you set the function to 0 and solve for x. Okay? So the official definition, the zeros of a function are the solutions. See, I said that word. Zeros are solutions, and they are also the x-intercepts. Okay? Look at me getting ahead of myself. All right, next, we're going to graph some piecewise. I kind of wasted some space right here because the actual question is on the other side. All right, and I'm thinking that I do not like the size of this graph. I think it's too hard to tell, so I'm going to actually draw my own. So I'm going to do the x, y axis here. Okay. Now, let's do these in parts, and I'm going to do these in colors, okay? So x squared, if x is less than 1. So the first thing, guys, I'm going to do is find out the value at 1. So if I do x squared here, that means I can get 1, 1. Right? So 1, 1 is right here. Now I get to fill it in because it's equal to. Okay? Now, less than 1 means I have to go to the left. So I'm going to go to 0 next. 0 squared is 0. Right there. Then I keep going, negative 1. Well, negative 1 is 1. So negative 1, 1. And then I know what the left side of a parabola looks like, so I'm just going to sketch that out. Okay. You only need a couple of points that allow you to know what it's looking like. Right? So let's do blue in this case. So now blue, I'm going to do my smaller one right here, or in between it, in the middle. So I'm going from 1 to 2, and the value is 3. So when x is 1, the value is always 3. It's a constant, so it's that horizontal line. At 2, because those are my 2 endpoints right there, so I want to definitely include both of those, it's still 3. So at 1, it's 1, 2, 3, and it's open because it's not equal to. It's open because it's not equal to. And then I'm going to 2, and at 2, it's also 3, and it's closed. And I know that that was a constant function, so it's just a horizontal line. Okay, now I see this third part is x, which means linear, right? Linear. So for all x's, I'm just going to put in x. But here I start at 2. So of course we have 2, 2, and then we're going to go greater, right? So we would go 3, 4, right? So we would have 3 and 4 because it's the same value. So let me start graphing that. So 2, 2, and it stays open because it's not equal to. At 3, it's 3. At 4, it's 4. And as you can see, it's a line, and it will keep going. So each of these pieces, the easiest thing to do for graphing these guys is make sure you make a table with the endpoints, this 1, 1, 2, 2, and then do something in between in the correct direction. Okay, so like this was less than 1, so we're going to do 0, -1, -2. This one's 1 and 2. You could have done 1.5, 1.75, and greater than 2, 3, 4, 5, 6, as long as you know the direction. Okay, so those are piecewise. Even and odd functions. So an even function is if it's symmetric to the y-axis. Okay, so even is to the y-axis. Odd is symmetric to the origin. Now, what does that mean? Well, the even functions, they mirror itself. So I can write that down. Mirror. Mirror or reflect over y-axis. And for the odd function, it rotates around the origin. Okay. Now hopefully that sounds familiar, right? Origin. Okay. But the thing is, we don't have a graphing calculator. So unless they give us a graph, we really don't visually know if it's even or odd. So there's an algebraic way to find this out, and that's what we are going to do here. And you have to test both ways if the first way doesn't count. Like, the only function that would be even and odd would be x equals 0. Okay, because that's the horizontal. So that reflects and rotates. So it's either one or the other or neither. Okay, so this is how we do it. We know that if it is an even function, that f of negative x is going to equal f of x. And we know that it's odd if f of negative x equals negative f of x. So how do we do that algebraically? And I'm going to show you here. So I'm going to test both ways. First thing I'm going to do is test even. Okay. So what I can do is I'm asking myself, is f of x, which is x cubed minus 2x, is that equal to f of negative x? Now, f of negative x means that we would substitute negative x in for x. So I would get negative x cubed minus 2 times negative x. If I were to simplify this, well, this would be negative x cubed. So negative times a negative times a negative is a negative. And negative 2 times negative x is a positive 2x. Are these two things the same value? They are not. So in this case, f of x does not equal f of negative x. So it is not even. Now we must test odd. Okay. So the first thing we're going to do is f of negative x. The reason why I'm doing f of negative x first in this case is because we already have it. It's right here. So I'm just going to transfer that over. Now I'm going to do negative of f of x. So that is just sticking a negative out front of the whole function. Okay. I did something wrong. Sorry. I just noticed. You guys see what I did here? I put down negative 2x instead of plus. Okay, that's an easy fix because this is plus, which means this down here is actually negative. So where is my blue pen? There we go. So this is actually negative x cubed minus 2x. Hopefully you guys have a pencil. But as you can see, those still do not equal. So it's not even. So let me change this. Minus 2x. There we go. Oh, now I can finish. If I distribute this negative out, I get negative x cubed minus 2x. And as you guys can see here, that means that f of negative x equals negative f of x. And since that happens, that means this is an odd function. Okay. All right, now we're doing it again. We're going to see if it's even or odd. So let's try even first. Even. Remember, the first thing we're going to do is write down f of x, or g of x in this case. So that's 5 all over 2x squared, or 2 minus x squared. Okay. Now I have to find g of negative x, which equals 5 all over 2 minus negative x squared. Okay, negative x squared, well, negative times a negative is a positive, so that means this just reduces to 5 over 2 minus x squared, right? Because that negative on the outside would become a positive, minus a positive is the negative here. Make sense? Negative times self is a positive. Okay. What do you know? That means that g of x does equal g of negative x. So that means it's even. Because it's even, we don't have to go any further. What did I say? The only function that's going to be even and odd is x equals 0. And this is not x equals 0. So we can stop at even. All right, this one gets a little bit more complicated. So I'm not going to write h of x to solve for even because I'm going to run out of room. So I'm going to try this h of negative x and see what happens. So h of negative x would be a negative x squared minus a negative x over 100 minus 1. So if we were to simplify this, this would come out to a positive x squared. Again, because a negative times a negative is a positive. This minus a negative becomes a positive. And the minus 1. So we can definitely see here that these two functions do not equal. So h of x does not equal h of negative x. So now let's try odd. We already have h of negative x right here. So I'm not going to write that again just for the fact for room. Okay, but I do need to try negative h of x. So that would be negative times x squared minus x over 100 minus 1. So if I distribute that negative out, I get negative x squared plus x over 100 plus 1. Do these two equal? No, they don't. So h of negative x does not equal negative h of x. So that means it's not odd. Well, if it's not even, it's not odd, it must be neither. All right, let's look at intervals. Determine where a function is increasing, decreasing, or a constant. Okay, let me try to get some colors here to help us with this. So what I like doing, guys, is when it comes to graphs, sometimes I analyze it before I start writing. So here, we always start at our left side. So if you see, as I increase, I'm going to color it in yellow. So this is an increase. Right here, I start decreasing, so I'm going to wait on that. Then I increase again here. I go constant, and then I increase here. Make sure you are going left to right. Decrease, I'll put in pink. And then that little part is not decreased, it's constant because it's going straight. So now I'm able to visualize my increasing, decreasing constant. So increasing is my yellow. So every time you do increasing, decreasing, and constant, you always use x values, not the y. So I start increasing at -4, and I stop increasing at -2. Now, at these points in general, you don't know if it's actually an increase point or a decrease point, so we're always going to keep parentheses. Okay. Now, I'm not going to do this pink one yet because I'm on increase. Then I start increasing again from 3 to 4. That's that little yellow. And then one more increase is 5 to 6. Okay. Decreasing, I had that in pink. So I'm going to go, remember the x values. Most people make the mistake because they put the y value in. So we go from -2 to 3. And where are we constant? That's our blue, from 4 to 5. All right. The mathematical way really to describe increasing, decreasing, and constant is that if f of A is less than f of B, decreasing would be f of A is greater than f of B, and constant is f of A equals f of B. So it's talking about the point or x values A and B if A is less than and greater than. Don't worry about the college-bound definitions. If you understand it in a different way, stay with it. This is also why I like the guided notes and not just the textbook. College's textbooks are very, very specific. Now, min and maximum values. Look at the function at the top of the page. What can you say about its highs and its lows? So it's not really the top of the page, right? It's in the middle. If you see the high point right here, low points are right there, right? So in other words, there's a high and a low where there is a change in direction. I can tell this by when I look at my graph because those colors are changing, right? Sometimes that's why I like using colors. All right, so there's your technical point, right? So the problem is there's a specific difference between a local max and an absolute max, okay? Local max is where there's a change from increasing to decreasing, okay? So an increase to a decrease. A local min is a decrease to an increase, okay? Now, here is about the absolute. Absolute max is the highest Y value. Absolute min is the lowest Y value. Okay. Also, you want to think max and min are coordinate pairs. It's very strict within calculus. Okay, let's look at a graph, an example here. So, y equals f of x below. Answer all the following questions. So first it says, find the domain of f. Remember that the domain of the x values. So what is the lowest x value you see on this graph? Well, I see -4. And the highest x value I see is 4. Now, do they include it or exclude it? Filled in means include. So that means we need to do brackets. Find the range. The lowest y value I see is -3. The highest is 3. And again, they're both closed. See, it goes down. The lowest is 3. It doesn't go beyond that. List the x-intercept. So where does it cross the x-axis? And you have to do coordinate pair for this. So the x-intercept is at -2, 0, and 2, 0. Y-intercept, if it exists, is where it crosses the y-axis. So it's 0, 3. Again, coordinate pair. Find the zeros. So the zeros, you only have to do the x value. You do not have to do a coordinate. A coordinate is the x-intercepts. But if you're just finding the zeros, it's what x makes it 0. So the zeros are -2 and 2. Now, f of x is less than 0. So less than means under. So where is it under the x-axis? Right down here. Under. Less than is under. If you see here, there's 2 parts of the graph. Like if I were to flow, I would have to lift up my pen to get to the other side to go down. So that means I'm going to have 2 intervals. Where does this lower end start? It starts at -4 and goes to -2. Okay. Now it is starting under, so that's a bracket. But because at -2 it's a 0, you have to put parentheses, because at -2 it is not under, it's on. And then where does it start being under again? It starts being at 2 and ends being under at 4. Don't forget, you need the x values, not the y's. All right. We are dealing with the same graph. So I'm going to have that graph, make sure it's in front of you, okay? Now this says determine f of 2. So if we go to f of 2, which means that the x value is 2, you look at that coordinate, it means it equals 0. Here we solve f of x is -3. So that means the y value is -3. So where is the y value at -3? Well, that is x is -4 and +4. Excuse me, guys. Remember, where is y negative 3? Here and here. So remember, I'm using that graph. All right, find the number of solutions. It doesn't say what, it says how many. So if we look at f of x equals 1. So 1 is right here because it's the y value, remember? So if I were to draw a line across 1 here, how many times does it hit the graph? It hits it twice. So there are 2 solutions. Okay, does f appear to be even or odd? So remember, what makes an even function? Even says it reflects across the y-axis. Odd says it goes around the origin, and neither is where it's neither nor. Okay. Now, if we look, right, it looks like it's even because if we fold it in half, it's on itself. So, even. Where are the intervals increasing? So if you wanted to put that color, remember we're going up and then down. So increasing is right here, and we're using the x values. So we're increasing from 4 to 0. Which, where are we decreasing? Well, that's where it's going down. Where does it start going down? 0 to 4. Remember, x values, not the y. List the local maximum. So where is the increasing to decreasing? Well, it increases to decreases at the point 0, 3. And where are the local mins? Well, local mins, remember, local mins means decreasing to increasing. Do we have any change from decreasing to increasing? No, so we don't have any. I'm going to say none. Now, absolute. Absolute is the y value. So what is the highest y value on our graph? 3. It's actually the same as a local max. Find the absolute minimum. So the lowest y value, well, the lowest y value is at -3. You guys see that on the graph? Okay. And then it says here, we're gonna like just summarize everything. All it does is give you more of your graphs, and it really focuses on if it's even, where it's increasing, decreasing, local, and absolute. Okay, even, this one's odd, cube roots are odd, reciprocal functions, odd, cubics, odd, and then that's it. Sorry, that's calculus right there, guys. All right, you can do 1.2 assignment right now if you choose to do so.